Okay, let's start this. Bit late starting, but it should be fine. I want to get cracking on with this, because I do want to play a little bit of Last of Us 2 tonight. So carry on from where I left off last week. Hey Andy, hey Prince Faze, hey Amok, hey Akmuffin, hey guys. Okay. So I think we left this last time. Oh God, I can't remember the buttons to compile now. That's it. Yeah, with some collision issues, that was right. Like some basic collision working, but some of the other stuff not so much. So I'm gonna take a look at the peek at this and see what the hell's going on there. There are a number of streamers doing Sonic 25th anniversary streams. Sonic is where I was just thinking that, yeah, it is. Oh, it is Sonic. Sonic is at least 91, I'd say, which would make it almost 30 years old, right? Yeah. Sonic is 91. Yeah, exactly, yeah. I wonder what that's about then. Maybe people have just forgotten what year it is. I mean, I'm starting to forget what day of the week it is, so it wouldn't surprise me. Right, so this is our player collision. Okay, so if I remember rightly, we were only updating every other frame, so I'm just going to turn that off for now. I'll just see what happens if I update every frame, because I have a funny feeling it's to do with that. Sonic is the same age as you. Yeah, see, it kind of works alright when you... Actually, it doesn't work alright. I'm not sure. Something odd going on here, so... trying to figure out what the hell that is. Has it not put me in stream mode? No, let me just put myself in stream mode on it. Get notifications from it. How am I getting that? Oh, it's my laptop. Turn my laptop. So we need to figure out why it's doing this. I think we had the collision positions correct. I feel like maybe I need to double check those. And I turned off all the right into those locations. So yeah. So really, I should have been drawing character to this location as well. I've left that in, but I've taken it out, haven't I? So that's not good. But he seems to be bobbing up and down a bit crazily, which is a bit weird. So I am going to draw to that location. Okay. Let's just put that there. This is Lukash, yeah. I've been using Lukash because it's just it's royalty free, so DRM, DCM or whatever it is free, so I can use it on the stream. He made some posts on Twitter a while ago about it, so I thought might as well use it. And it's good music as well, so. And I remember to announce this time, yeah. I forgot to put it on Twitter, but doesn't matter. Doesn't matter. The people who matter are here, right? That's all that counts. I do have a request from Hayes that I missed on Saturday, because half of the time I don't know if Hayes is just shouting something at me or he's requesting something. Unfortunately, my chat doesn't show that it's a request, so I have to keep an eye on that. So if Hayes shows up tonight, I'll possibly put Lazy Jones on. If not, I'll save it for Saturday or Thursday. Okay, so it looks like this position is fine. Problem is he doesn't fall when he's on this character, so it also seems to be the collision seems to stop here, so I might need to fix that in a minute. Just like that. Let's see what the hell's going on. So we check these two positions. Let's just check one position and make sure it's working with one position. Just maybe it's to do with because that looks pretty solid. Oh no, there's still places where it's a bit iffy. But there, what is it doing there? That's I'm not sure what it's doing there. Okay. So it comes to here. If it always jumps to there, then we shouldn't get any glitching. So maybe it's something to do with this. But I think the fall routine is fine. I'm going to slow it down again just to see if I can see what's going on. So let's slow it down to a quarter of the speed. Yeah, it's like it's getting the wrong data half the time. Because the behaviour should be the same. It should be deterministic. It should always do the same, but it's not. It's doing slightly different things each time. Hey Drixie, welcome to the stream. Thank you for the follow, dude. Yeah, it's weird, isn't it? It's really, really flaky, the collision detection. I'm not sure why. Okay, so let's put this thing back in. Might have to write something around this to make this a little bit easier to detect what's going on, because I think the problem is with this he's not going to fall because it's always going to be stood on a letter, so I can't push down through. But there doesn't seem to be any problem with where these letters are appearing. They're always appearing on his left hand side, which is correct. It's just when there is a gap, he's not sure. He seems to fall incorrectly. So this is the collision that we're doing. We're saying, actually, I wonder if we just clear the flag and return. So we're always gliding. How does he fall? Does he fall neatly, or does he fall with that strange behaviour? Okay, he's not falling at all. I feel like there's an error somewhere. No. Probably a mission hash, yeah. Finding that one of the things that's kind of hard to get used to, actually. I think it's 0. The lack of the hash symbol. Fall Guy remake. Stop trying to add games to my list, Hayes. Hayes, I noticed I missed one of your tune requests, so I apologise for that. I'll keep it in the queue. I'm not going to play it tonight because I have got it on Spotify, Lucas's Spotify playlist, but I'll play it on Thursday or Friday or Saturday in the next one. Unfortunately, unless you tell me it's a song request specifically, I won't know unless I happen to go and look at my reward panel, which I don't look at all that often. So, and I do remember you just declaring in capital letters loudly "Lazy Jones," and I wondered what you were on about. Yeah, I blame the mods. Okay, right. So why is he now floating and not? I think I'm misunderstanding what my routine is doing here. So this get char collision, I was hoping would return clear for fall, set for not fall, but it seems like it might be the other way around. No, he's still floating. So I feel like this is just completely wrong, this routine. Let's have a look at what it's expected. So, full get char collision, jump if carry is set to no fall. So if the carry is clear at this point, it should fall. Okay, let's do it differently. Let's return. Let's just return what's in that location and test the value instead. And change this up to return a collision value instead, but let's just return what's in the accumulator. And then jump if not 0 to fall. Oh, I think it's to do with that because the collision flag seems a little bit weird. No, it's still not smooth. There's still something like that. Why is that? Like if I'm close to the edge, so it's like there's a carry being added somewhere that's not. I am going to put a breakpoint in a particular location to check the value coming out of here. Make sure it's consistent, because I have a funny feeling it's not consistent. So this is in player collision, so let's have a look for that in here. Player collision 01 F5, so let's go and have a look around that location. Check the image. You get drunken Z6580. Yeah. Okay, so let's find a place where it's weird. It's weird everywhere, but let's find a place where it's actually showing varying correctly. Oh, annoyingly, that's kind of almost working. Ah, there we go. Seems to not be breaking in the same way now, which is a bit annoying. Let's turn that off. Nice. What is going on? I need to get it in one of those states where it's kind of hovering. There we go. Debugger. So is it 01? Things have moved again there. Okay. Layer collision. So let's kind of have a look at O2EC. I went for a lie down about 5:30 or something like that, and then I woke up at 9 o'clock. So that's me not sleeping tonight. So was a reason I'll play afterwards later. Okay, these are the two core routines. So at this point here, I'm expecting DE to be the position underneath the character here. So I'm going to open up the VRAM viewer as well, so we can see. Have a look at the background now. Let's just turn the grid off for a second. Actually, no, just leave it on a second to load. Okay, right. So I wish I could make this bigger, but unfortunately I can't. Actually, have I got a magnifier? Maybe this will magnify it. Oh wow, okay, that's not what I was expecting. Never mind. Yeah, wasn't that like going live or something like that? Yeah, swap shop. I think they kept the same phone line though for going live as well. Same studio and everything, wasn't it? But yeah, I remember. Was it going live, or was it? Well, it was the one before that, I think. Yeah, it was probably the only phone in the in the studio. Okay, so putting a breakpoint here. DE is C0A0, so click on here. Well, straight away that's wrong. Is it actually broken at that point? No. Okay, now it's broken at that point. So it's a 9D60, which is this position here, which looking at the character looks correct. So that's fine, but it should be blank, so the guy should start falling. So we should jump to this position here. If I just skip through, step over. Okay, so F3, which it does. So that's good. So I'm going to run it to breakpoint again. And this time we've got 9D60, which is fine. Still 9D60. So I'm just going to run it a bit like this. So you can see him jumping around like crazy. This value is not changing. However, the value in the accumulator is changing. See, it's FF here. D is the same. So it's FF here, so he's going to go down. If it's 0, it's going to go up. FF, he'll go down. FF. No. We can see this FF here is wrong. That should not be the case. Oh, and I know why. I know why. We can't read stuff from the VRAM at this position. We have to read it in the horizontal stuff. Okay. Okay, right. That's why we're getting problems. Okay, so we have to wait for the horizontal. Who is that? Thank you for the hosts in now. Oh, thank you for the host, Acmafin and Andy Magic Knight as well. I missed that. Thanks, guys. Okay, so at least I know what's going on now. So what I need to do is I need to wait for that horizontal, the horizontal blank, and I cannot remember for the life of me how to do this. So let's see if I can figure it out from here. So there's the horizontal blank interrupt, but I don't want to use the interrupt for this. I just want to wait. I just want to hold any processing at this point until let's just get rid of that. I'm going to hold any processing at this point until we're in the horizontal blank and then do this. So I think there is, it's not that one. I think there is something for this. Can't remember what it is though, so just need to kind of scan through a little bit. But actually, the other way we could do this is we could move player collision into an interrupt instead. So let's think about this. So in the moment we're doing it in here. And this happens after the vertical frame stuff. So maybe I don't know, player control needs to happen after it as well. Let me try something. Let me try just moving that into the interrupt, because this might be enough to get it to work. So set frame ready flag. So we'll actually do it here. And then if I get rid of it from here and I move the player control to happen after the sprite's been set, might actually fix it. This is the V blank interrupt, I think. Hope it is anyway. Yeah, the V blank interrupt. So this should only happen once a frame. And it should happen before all this happens as well. Hey, Furrow. I think it's because they wanted to keep it fairly similar to the way the NES worked. So they've kept the same kind of arc, like the video flow, and because they lock the video RAM down, you do need to make sure it has some time to do other stuff as well. Okay, well. Okay, but the problem is now it's not showing any of the freaking map for some reason. Let's just get rid of that a second. Okay, for some reason calling player collision in here breaks it. Couldn't tell you why. But look, he's a lot smoother with his movement. So it's definitely to do with that. I think it might be enough to just... Actually, what have we got in horizontal blade? We've got... If we get rid of that, and I have a look at the horizontal blank, because what I can do is use this frame ready flag. And have a second one of these. It's just the horizontal blank frame ready. Let's have a look. Where's the horizontal blank set up? LCD stat interrupt. So that is this one here. God, this is so frustrating. There is. I'm just wondering if the best way to do this is on a vertical blank, just to grab all the collision that's around the player and just store it somewhere. Or to take a copy of the screen area. The problem is as well as the V blank is so small. I'm going to put it. I'm just going to put it here for now. If we start running out of room, we can shuffle things around. At least I know what's going on there. I've got to remember that every time I do this, that there's probably going to be something that I'm trying to do that I can't do at that particular time. So it's remembering that the IO RAM can only be written to like 50% of the time. And so what it was doing is it was trying to grab the collision sometimes when it was out of the screen, sometimes when it was in the screen, and so we're getting different values back from the collision. So let's do that again. Let's put this up here. And this time let's in the collision just wait for that H blank and see what happens. I think we should be alright. We've got quite a lot of processing time to do things. Also, it's worth noting as well that I'm only running this at 1 megahertz at the moment. Or 4 megahertz, whatever it is. It's not using the Gameboy Color boost mode, which I will implement at some point, so it makes sense to kind of, I don't know, use this kind of method for now. Okay, H blank. H blank apparently doesn't exist in this document. There it is. During H blank. Right, here we go. Bits 1 to 0, read only, LCD status. So I need to read. And we do the same thing here with is it our stack? Yeah. We do the same thing when we're setting the fonts as well. We have to wait for V blank to set the fonts. So during H blank would be 0. So do this for binary. So if it's obvious that we're doing check. Actually put a comment on here. I mean, it's not ideal, but it will be fine, I think. One of my family asked why I chose Pro and my time it's close to it. It is, you might as well be writing magic spells half of the time. Oh, still getting issues. Well, we're still getting issues. Maybe it's not enough what I've done. request and this. All right. Are you making more requests? No, you're not making more requests. Yeah, it won't be any SIDS tonight. I have turned them off, but I will do them on Thursday. So as soon as you, or Saturday, whenever I see you on Thursday or Saturday, Hayes, I will play your Lazy Jones and then try and make a better job of keeping my eye on that request list. Okay, let's have a look what's going on. So play control, play collision. So let's go and have a look in here again. Okay. Java is the black magic. I hate Java. I really do hate Java. It's such a bloated language, it's ridiculous. Yeah, okay, so we're getting the same thing again here. I don't know which one of these is. Yeah, this is the stat thing here. Why isn't that working then? That should be fine. So I want to check how I do the font loading, because I have a funny feeling I'm just doing something really wrong here. Not that one loader. I don't do it in there either. Where do I do it? There? No? Where do I do it? Init fonts. Where is the init fonts? Initialize, that's the one. Oh, do I need to do that? So I think I'm just in some kind of brain misfunction today. Okay, I don't actually need to do compare A, let's do that apparently. Yeah, is the map using the right blank character? Yeah, I mean it's definitely using the right blank character. The problem, you can see it here, is like it's not sure what to do. So at some point it thinks it needs to go down, then it thinks it needs to go up. So let me just double check that the blank character is correct. Maybe it's not. Maybe you are right and it's doing something. But the thing is, the address is the same in the debugger. Yeah, tile 0, tile 0. These are all tile 0 and tile 0 there as well. Yeah, we get different results. I think it is just to do with that H blank stuff, so I'm just going to play around a little bit with this. Let's see if I can't get this to work. So like, where's he gone now? It's not even showing. So in this one, I do it by weighting that. Hey Genos3, welcome to the stream. Oh, that seemed to be... Oh, that's much better. Technically it runs at 8 megahertz when it's boosted, but people tend to call it 2 megahertz because that's the clock frequency or so, and that's the clock cycle frequency rather than the CPU frequency. So everything is multiples of 4 cycles. But I say call it the speed it is. I mean, it is 8 megahertz, right? That looks to be working correctly. Okay, so I think I need to re-understand what's going on with these commands. So let me just grab the Z80. Because I thought you had to say which register you were doing it on, like that, but that seems to produce different results, right? Yeah, see, look, the results are different, so I want to have a look and see what they do. In fact, I don't need this, I can do it through my page. I still need to read that book and figure out the best way of digesting the information. Instruction set, right, okay, so there doesn't seem to be an and without anything. It's just, it always seems to be and accumulator something. So I'm not sure what the difference is there. So it does about 2 MIPS. Yeah, it does in turbo mode, so... Vinegar crisps, yeah. I didn't realise that was a very British thing as well. The old salt and vinegar crisp, but yeah, apparently it's not very common outside of Britain. I think there are places that do them, obviously, but I think it's mostly a British thing. Shame, because some salt and vinegar crisps are amazing. Okay, you get char collision. Let's see if we can find that. Okay, get char collision, check HRank 0550. So what I want to do is look to see what the values are at this location. There's so many of these windows open, I'm going to close them all actually. Which probably means it's going to give me a different value. Oh no, 0550, okay, so I just want to see what what is actually in that location. What is the difference between those two commands? Because I think it's starting to become problematic for me. So GBA CPU at 60 minutes. It also ran at 16 MIPS. I'm not sure with the GBA. I don't know, because I know it used ARM, so I'm not sure what the ARM instruction set is like per instructions per cycle. But okay, so it does this funny load IO thing, which is fine. And I'm going to make a note of what this is actually displayed. So this is giving me E603 followed by FE00, and those instructions are a comma ever. So now I'm going to do it without that, which seems to fix it for some reason. Take a look at the same piece of code. So stuff is in the same place. Actually, that didn't. It's still buggy. What? but it seems less buggy. That's the weird thing. I wish I knew more about Z80 before I started this, but it's fine. It's all a learning process, right? Yeah, it's exactly the same values, no difference. So they do mean exactly the same thing, those two things. So I don't know why that's suddenly working and it wasn't before. I think I can test. Oh no, I can't test if jump with 0, jump with non-zero. Okay, so I think I'm just getting lucky with it. I think I'm just getting lucky with it because it seems to be fine here now. Definitely not getting any of those weird oh god, weird areas where it's pausing. So I think this routine is alright. I don't like it, but it will have to stay for now. Let's just slow down the collision checks a little bit. Play control, play collision. Okay, so let's do this a little bit less often. Just see if things are fine. I think the Game Boy Advance had stuff that made it easy to do 3D. I don't think it relied purely on the speed of the CPU. I think it had some hardware to help it along. I might be wrong, but that's my impression when I see the stuff that it does. Okay, this kind of looks all right now. I mean, obviously the jump is not a jump, but we'll do that in a minute, because the other thing as well is this is using up and down, and it won't be up and down. For a start, there'll be no down whatsoever, so pulling down won't do anything at the moment. It just makes you freak out like that. But we'll be using the jump button to do the up, but for now it's just up, but we'll move it to a jump button once we get the jump actually working. So it looks to be fine. So let's put it at the right speed now. And let's think about the jump state. I think we can move on to that now. So I'm fairly happy with that. Yeah, that feels about right, I think. Oh, we just need to turn the collision thing on the other side as well, so that one to be back on. Oops. Change that back to the carry flag. Flag, yeah, okay. Compare N, compare A with N. This is basically an A. Yeah, I mean, it is exactly the same as A, comma N. That's the thing. Compared to a value to N1, because you can only use that compare anyway. Oh, hang on, compare. According to the manual, the compare command is just compare with accumulator compared to a value to only one operand. The results are thrown away. Use with N equals accumulator. Okay. Okay, I mean, they both produce that and that, both produce exactly the same opcode, so so they're equivalent, but obviously you can do, I guess you can do things like that in it as well, which is what it's saying. So So if you don't put the A there, it just assumes it's A. The assembler just says, okay, this is A. Because you're always comparing with the accumulator. So if you put a number on this side, so actually you can probably miss the A off completely in most cases. So yeah, I think it's just they've probably done it for kind of, yeah, it's a really stupid chip. I really kind of regret picking this one. I wish I'd have gone straight for Game Boy Advance actually. Okay, this is kind of looking alright. I'm going to take a quick break now, so I need to go and quick smoke and go to the toilet. And then when I come back, we'll actually put a proper jump routine in, because at the moment this is just very janky and horrible. So, oh wow, GBA didn't have any external processor. The 3D effects were solely done on the CPU. Mode 7 was done in software. Wow, okay. That surprises me. But then again, they did use ARM, and ARM is a lot faster at those kind of mathematical operations. So, which I think is why Apple are trying to move to it now with their MacBooks. Which I think is a stupid move by them, because they're doing it purely for money purposes. Because it allows them to sell the computers at the same price, because they're not going to reduce the price. And people are stupid if they think it is. But that will cost them a lot less, because they won't have licensing deals with Intel. But the downside is that everybody's going to have to recompile their applications, and it's going to create a kind of an even bigger divide between Mac and Windows applications, which I think is really bad, to be honest. But what are you going to do? Apple are Apple. They've got all the money in the world. They don't care, so they just want to make more of it. All right, I'll be back in 5 minutes, guys. Be right back. It wouldn't surprise me. I mean, you know, I do have an iPhone here, which is my test device, and I have got an iPad somewhere which is a test device as well. Well, don't know where it is. So I do use them. So it's not like I'm completely without kind of fault, but they're work devices, so it's not like I'm paying for it. Okay, I had an idea as well while I was outside, how to get rid of the H-blank stuff. So when the map is drawn, I can do this now. In this area here, we draw the map to the screen. But what we can do is, when we finish drawing the map, we can make a copy of that map. We do it here. Copy map to shadow map, and basically what we'll do is, in RAM we'll define an area where we'll just have a copy of the screen, because the screen doesn't update collision, it stays the same. So yeah, I do want to learn ARM. That's going to be the next one. Yeah, they will leverage the Intel heat issue, which was their fault. And the thing is if you look at how what they do in the kind of quest for thinness, they make some really bad kind of design decisions around that. And the thing is a high-powered laptop with an i9 in it has to have a really good cooling solution. So the one I've got, the Asus ZenBook. Just to show you how this works. So this is an i9, which I think is around about here somewhere, around about here on the back. But what they do is, I don't know if you can see this, but when you open the case up, the back side of it here raises the whole laptop, so you get cooling all the way underneath. Plus, it's a noisy beast as well. It does make an absolute racket when it's in full speed. But it doesn't slow down. It never. It does thermal throttle if I do some like crazy intensive stuff on it. But for things like gaming and stuff, it's perfectly fine and doesn't thermal throttle. It's an i5 laptop cooler. Yes, definitely. The i5s don't have hyperthreading, so they tend to run a bit cooler than the i7s because they're doing half as much work. Basically, they don't have as many threads running. So this is all aligned to pages, so I'm going to use this area now to do a shadow map, which we're also going to align to page. And so I need to work out how many bytes I need for this. So we're going to copy this section of VRAM, just these lines here. So we're going to need from line C, this goes all the way up to 9E. So let's make it keep it nice and rounded. Let's do 768 bytes. That'll give us down to here, and that should be more than enough. There'll be a lot of blank space in here because this stuff won't be copied. I mean, we could essentially copy this a line at a time, but I'm just going to do it kind of straightforward. So for now, I'm just going to reserve 768 bytes. So before I use that, I just want to make sure that that doesn't break anything. Okay, see, everything seems to be fine again. Okay. So just to make sure that this is working, I'm going to turn the H blank stuff off in the collision so we can see the bug, and then I'm going to use it to adjust these values in here, and hopefully get this working using shadow ramp instead. So yeah, so you can see the bug there. It's only reading collision properly when it's in the H blank, so quite often we're getting an FF back instead of a 0, and so it thinks it's collision, and then it's doing a snap, which is moving it up, which means that it's just kind of getting stuck in a loop. It's only when you start actually using processing time that it starts correcting itself as the kind of time that it processes moves into the H blank. So we're going to try and fix that by making a small update to the map draw routine, which is just we're going to copy the data from let's put a note here. What we're going to do: copy data from 9C100 to 9EF into shadow map. Okay, so this should be fairly straightforward. We can load HL with the value 9C100, and we can load DE with the location of shadow map. I forgot a thing called loop in here. I bet we have. So let's call this loop. Let's just call it shadow loop. It's obvious. Right. So what we need to do is we need to copy data from HL, increment that value, and we need to store that at DE, and then we need to implement DE, and then we're going to load the accumulator with the contents of H, and we're going to compare that to 9F, because that would mean we've reached the end of this. Jump, if it's not that, to shadow loop. So I'm going to give that a run now. So it's going to slow down the map draw, but it's only ever so slightly, and we're not going to see a huge difference here. Yeah, this is I think this is a 2070. I think, I can't remember exactly what's in it. It's more than enough what I need. I don't actually use it for gaming. It's more for coding and stuff. I got it for the dual screen. For those who haven't seen, I definitely recommend these. This is the future of laptops. I think this extra screen here, I don't know if you can see that. This extra screen here is just amazing. It's a really nice kind of setup. Allows you to kind of, and it's all touch screen as well. So you've got a 4K screen up here, and then you've got a 4K screen down here as well. load in like that. See, so then you can quite easily store stuff on this pad down here. It makes it really handy to especially for coding, because I can put all my debugger and stuff on the bottom and have the top as just so I can have my Vice output on the bottom and I can have my debugger on the bottom and have the full code window free at the top, so it's kind of nice. Okay, so what I want to check is I just want to have a look in the debugger just to make sure that we do have actually the screen data at that location. So I'm going to go down and have a just look at the first couple of rows of screen data. So 62, 63, actually you can kind of see it, it's kind of laid out like the screen anyway. And then I want to go and compare that to Shadow RAM, which is Shadow Map C200. So it's going to have a look at C200. Yeah, and it has copied it exactly, so that's good. So now we can use that and not have to worry about the H blank issue, which means we gain a few extra cycles every time we do that, which is probably going to be used quite a lot for the enemies and stuff, so it's probably a good idea to do that. Okay, so in collision here, get char position. So there is a routine in here which adds 9C, so instead of adding 9C, we're just going to add shadow map, and we need to shift that by can I do it like this? I think I can do it like this. Shift that by 16, that should give me the upper bounds of that. Hopefully this should work properly now. Okay, no, it seems to have stopped here for some reason. Okay, maybe that's... Let me just put the hard-coded value in first and then see if that's working. C2. Yeah, there we go, and it's working perfectly fine now. And now I don't have to worry about the H blank issues at all, which is good. That's how we want it, ideally. So. I'd never buy a touchscreen on a laptop then. I think it's stupider than Apple released one. Is their next laptop going to be fully touchscreen? I'm surprised they haven't done it already. I mean, it's such a common feature now on laptops. No, still not. Okay. It's actually really nice on that one. I think it was less. Yeah, I guess. Screen too thick. Yeah, it's going to add a millimeter to the screen thickness, isn't it? They can't have that. Okay, so how do I get the upper byte of shadow map? I wish there was a better way of doing this. Right, I wish I could just do that, but I don't think that's going to work. Oh, no, it hasn't. Okay, it's M55. Okay. So what do I need to do? Can I thought that would do it, but oh no, it's not. It's 8, isn't it? Not 16. God damn it. No, that's why. Okay. Just make sure that's run correctly. Seems to have done. Yeah, everything's good. Okay, cool. Right. Cool. So now I don't have to worry about the screen. So actually, we've got the entire screen RAM, the entire sprite RAM, all copied into this area of RAM here, so that we can read it at any point. So. 144 hertz, you mean? Megahertz. 144 megahertz screen would be amazing, right? Not that you'd ever be able to power anything at that speed. Yeah, so I've also got I've got a Surface Book as well. So I've got this thing, which is my old laptop, which I'm giving to my son when he's when he comes down next. And this is a really nice laptop. I actually really like it, but it's just the touchscreen. It was a bit gimmicky on this thing, so and it's very top heavy, so it wants to fall over all the time. So, but it does have the advantage that you can pull this off and use it as a tablet. So that's kind of nice. But it's just not the best. It's not the best device for developing on. It's a bit small, the screen. The touch is a bit overly sensitive on it as well. Okay, right. Get rid of that now. I'm pretty confident that that's going to work properly, and this is going to be as efficient as we can get it without completely refactoring it. Okay, cool. Let's do the jump routine. Okay, so jump routine is going to be one of these flags here. So we've got these two flags that we've set up. We have a jump fall index. Now the jump was different, if I remember rightly. So let me just open up the original game, grab the jump table for that. It's in tables or something. Oh, the code in here is so messy. I have no idea where I put it. Utils? No, utils. Not. There we go. So this is our fall table, and that should match what we've got in here, which I think it does. 1 1 1 2 2 2 3 3 4 4 5 5, which it does. That's fine. So I just want to do the jump table, so I'm just going to copy it from here, and then we'll make it match the style above. So the only difference between these two is that I think the jump is slowed down, sped up at the beginning a little bit, so that it doesn't feel so mechanical. It should feel a bit more kind of floaty at the top and a bit quicker at the bottom. And so the jump table is a different length. So let's go ahead and implement that. So we've got this player collision thing here. This is checking, first of all, if we're falling by checking the player state. So we now need to do the same check with jumping as well. So first of all, let's go and change the jump routine. Let's actually put it on a button, I guess. So we need to do this. So let's get rid of the let's get rid of these things for now, and let's just do some checks. So how many buttons do we have on this thing? So we've got two. We've got A and B. So we're going to need one for jump, one for the effect, the timeline effect, and there's the shoulder buttons as well, but I don't think they exist on the Gameboy Color, so it's just these two buttons. So A, I think, will be fine for jump. So first set to read buttons. So this will be something like P1, F, get button. There we go. We'll load that value, store it in joy temp. Right, okay, so now we've got that value in the joystick temp. So now we can do some checks. So let's check for jump. So before we can do jump, we have to first check, are we falling? Because if we're falling, we can't do jump. So let's get the code from that. Jump if it's non-zero. So if we are in a fall, then we go to done jump. Okay. Then if we can jump, then what we need to do is check if we're already jumping. So actually we can check both of these things together. So if either of these are already set, then we can't jump. So if we're already jumping, we can't jump, and if we're falling, we can't jump. So add those two together. That will allow us to check both of those things. So now we can actually check the joystick for a button. So we can do, I don't know which bit we need to check here, so let's go and have a look. This can be one of these, isn't it? Joypad input, here we go. Button A, bit 0. Okay, so just check that that's the same. Yeah, okay, so bit 0, A. So we're checking if bit A, if that one is set. Jump if that's non-zero, because if it is set, then the button is not being pressed. These are the same as the Commodore 64. They're held high and they're pulled low when the button is pressed. So that the Surface Book is 3:2, which is a really weird ratio, I think, for a device. Feels really weird, feels super square. Okay, so let's just do the same thing here. Let's just decrease. So we're not doing a proper jump yet. We're just going to do this this check here to make sure. So I think what's going to happen is you're just going to lift up one frame, one bit. I need to figure out where the buttons are now on this joypad. Okay, so configure game controller. No, configure keyboard. Press and hold the button for right. Okay, right, left. Bring the map to S, okay. S and A, okay, let's just cancel that. Okay, so it's definitely doing something, but it's moving in the wrong direction because I haven't done this. Cool, so the A button is doing something. The up and down don't do anything there. It's good. Made it loud. Yeah, C64 is 1610. Although technically, only the visible character screen is 1610. The actual, if you start including the borders as well, then you've got some really weird aspect ratios. And it depends on the TV as well, because CRTs back then didn't really have a defined safe area on the top and bottom. So you would, on some screens, you would see more of the bottom and top and sides than you would on others. So. Okay, so we've started a jump, so we need to reset all the jump stats. So the first thing to do is we need to set the player state to say that we're jumping. So let's do this again. Let's go with this, and let's put a note in here. We are jumping starting jump. So set up. So first of all, we need to OR the accumulator with state jump. We need to make sure that that's set, and put that back into player state. Then we also need to reset the player jump fall index. What was the quick shortcut for doing the forgotten already? Oh, it's alright, there we go. Okay. I've got to remember to do this instead of doing load accumulator with 0. That's a much quicker way of doing it, so it uses one less byte. And then that needs to go into player jump fall index. And that's pretty much it. That's pretty much all we need to do. Then down here we need to actually implement the jump routine. So pretty much the same kind of checks that we're doing here. I'm not gonna do the collision just yet, but we will have to do collision at some point so that we bounce off the roof and not jump up through it. So what do we need to check here? The only thing we need to check is so with the falling, we actually check, are we jumping? We're actually setting the falling flag here as well. We're not going to do that directly in here. We don't need to set the jump flag. We will need to set the fall flag if we jump and we hit our head on something, or we can just turn the jump flag off, which is probably the correct way to do this. Although we might need to set the fall flag to prevent us from doing a double thing. Oh, has everyone seen the Mega 65 Geos running in 80 column mode? It looks really nice and super quick as well. Kind of looking forward to using that. Interlace means a half frame rate. Yes. Well, kind of. You get full frame rate, but only half of the screen updates. So it causes a lot of problems with some C64 games as well. So if you use some cheap scalers, they actually output an interlaced mode. So what it does is, if you've got a game that's got odd even kind of power blending, then what you will see is you will see really glitchy kind of blending on those devices. So you've got to be careful. That's one of the reasons why cheap interlace to LCD TVs can be a bit of a problem. It's less of a problem when you're streaming it, but through a TV it can look freaking terrible. That's why the OSSC is so good, and obviously the Ultimates gets rid of that completely with the HDMI output. So okay, so jump, if jump is not on, then done jump. Otherwise, what we need to do is basically what we do with the falling stuff here. So we're going to load the value of jump table. Apply jump. But this is not going to be fall table, it's going to be jump table. Then we need to add our stupid values here. No. That's pretty much that. It's pretty much that entire thing. With one small change. So what this is doing, this is taking our jump table address, then it's adding our jump fall index. Because we don't have index registers, we have to actually update this value directly, and to do that we load the index from here, and then we add it to L here. And then we add 0 to H using the carry, so if it leaks over it will carry. We could probably align those tables and avoid having to do the second add, but I still don't know how to do that properly, so aligning this is a pain. Then we load the player Y, and then here we need to subtract, so we're going to subtract the value. Oh, actually, this is going to subtract HL from the accumulator. So actually, I think what we need to do what is it? Yeah, this is going to subtract HL from the accumulator. We need it to be kind of the other way around. So can I do it the other way around? I bet I can't. So I can subtract the byte pointed to by HL from accumulator. Okay. Subtract the value in register 8 from accumulator. Okay, so I can actually do it this way around. So I need to load. Use B here, I think it's fine. Load B with the byte in here, and then should do it this way around. So load B with the value in the jump table, load accumulator with the player Y, then subtract from the accumulator the value in B, and then put that back into player Y. So what this should do now when we run is we'll move up the screen really quickly, because we're never running out of the we're never closing the jump tables, never finishing. We're not advancing through it, but it is subtracting all the time, and that seems to work, so that's good. I just wanted to make sure that was working. I know it's in 640 before it's at 60 frames per second. Yeah, it was kind of a problem with quite a bad problem with some of the Xbox 360 modes as well. So Xbox 360 had some weird kind of 1080p interlace modes, or 720p interlace. I can't remember what it was, but it had some strange interlace modes. And while it looked great on the UI, the moment anything started moving, it looked awful. It looked really, really bad. So I definitely kind of avoided using it. I think it was 576i actually, not 720. I might be wrong though. I can't remember. Okay, so next thing to do is increment the fall index, which we've already got here. So I'm just going to copy this chunk here and adjust it for our jump routine. This is actually now jump index. So we're going to increase that. We're going to compare this with a jump table and not fall table. If we've hit the limit, then we'll decrease 8. But then at this point, what we also need to do is we then now need to turn the jump state off here as well. So I'm actually going to do it like this. So I'm going to actually store that there, and then I'm going to load the accumulator with player state, or the byte that's in player state, and then we're going to AND that with 255 minus state jump. That will turn off the jump. And then we can jump to double jump. Okay, so we don't need to do this again. Now I do wonder how high this jump is going to be. Maybe we need to tone it down a little bit because the screen's smaller. And I've just copied the jump routine directly from the jump table directly from Doc. In fact, that's not even advancing for some reason. Something has gone wrong. I have a funny feeling I've got a bug because, yeah, there we go. Skip limit already defined. Okay, this is because the stupid way these labels work means we can't just use that. We have to put another number. Really nice if they implemented those. I'd love to see a kick assembler version of Z80. It'd be so much better. Probably feel less like screaming all the time when I use this. I'm noticing we play a jump table. Why is that not? Is it 2 underscores maybe? Because they didn't put a capital there. Okay, yeah, so the jump's a bit high at the moment, but it is there. And there's no upwards collision, so we'll do that in a second. So first of all, I want to just tone this jump down a little bit. So what I need to do is I need to compare this now against the original game, because I need this to be relatively close in kind of behavior, because actually the controls and the amount you can jump is really important. So just see how high you can jump. So this is 2 tiles high. 1, 2, 3, yeah, 2 tiles high, and he can jump just a little bit higher than that. So it looks like he can jump about 2.5 tiles high. So let's see how that compares. So that means he would be able to jump to about, I need to do it away from there, maybe there. Okay. Oh, actually, he is jumping about the same. He is jumping, well, it kind of makes sense actually, because the tables are the same. He's jumping exactly the same amount. But I think we need to tone it down. So I think we're going to have to, because otherwise, with the smaller screens, it's going to be a bit too much. So let's tone the jump table down a little bit. So let's trim off one of them. One of them. Let's have a look how that looks. So that is it is a little bit less, but it's not too much that it looks wrong. Let's have a look at the speed he's going as well. So it's a little bit quicker, but I'm not too fussed about that. It's probably because this is 60 hertz as opposed to 50 on here. So that speed difference is, I'm not too fussed about that. It's just a bit faster kind of paced gameplay, that's all. Okay, so let's put the roof collisions in as well. Oops. Yeah, I feel all right with that. Still got that weird correction. That shouldn't be happening. That should not be being seen. Might need to rearrange the collision routine a little bit, but You can see it there, he just goes through the box ever so slightly, whereas on here it doesn't. Did Doc go on a diet between versions? Yeah, Doc is quite fat in this version. It's a kind of side effect of the crazy double width pixel thing. I didn't want to make him the same width in this, so he has kind of slightly dieted for this version. It looks more exaggerated because I've only got the side-on view at the moment, but the side-on view is pretty much the same. It's just his legs are a bit smaller than this version. Okay, cool. So yeah, let's put the roof collisions in, which should be fairly simple tasks because we've already got a routine in place for falling. Where was it? Okay, so we can get rid of this now. I think the only place that label is used is there, so let's change that to buttons. Put that there. And I can get rid of this. There we go. So we do have these checks here for the collisions going up. So what we'll do for going down, so we'll do the same thing for going up. So add current fall value. No, we want it in the jump in here. So apply jump. So the first thing we're going to do is before we jump, we're just going to check we can jump. And this is just going to check the upwards position. We probably don't need to check in. Actually, no, we should still check 2 positions. Sorry I'm late. Broke Hunchback playing Minecraft. No worries. Welcome to the stream, dude. Okay, so this routine is kind of nice because we don't really need to do much other than change these offsets here. So the offset will just be 0 for the top, and that's because we look at the sprites in here. You can see the top of his head is right up against the top. In most cases, there's a few little bits where it's 1 off, but that's fine. We can always reduce that down if it feels a bit too kind of stingy with the collision, because sometimes the collision can feel a bit stingy if the slightest pixel makes you stop. So we can always kind of make it a little bit more spongy by increasing. In fact, let's make it 1 line so it's a little bit spongier. And then we need to change this to no jump. Now this actually probably needs cancelling into this one here. So actually probably what we need to do here is end jump. So if we do hit something, we're going to end the jump immediately. And that hopefully should be all we need to do. We shouldn't need to do anything more than that. One thing I did notice though with the collision routine is that the top 2 rows of characters didn't seem to do anything. Yeah, there we go. Now obviously we're colliding on anything at the moment. This won't be collision eventually, but we don't have any collision map data for this. But if I try and get up here, so I can stand on the top of that, but actually I can jump here as well. I don't know, it's kind of colliding kind of alright actually. Okay, maybe that's fine. It looked like there was no collision up here, but it looks like there is. So if I stand here, I'm actually colliding on either side there. So maybe we need to bring these in a little bit, these 2 points, because they're checking kind of where the feet are, but maybe it either needs to just be 1 in the middle here. Yeah, I'm going to bring them in a little. In fact, let's try it with just 1 for now. So let's make it in the middle of these 2. So if I do it like that, get rid of this one. because obviously the less of these collision checks we do, the more efficient it's going to be. So yeah, it it's kind of funny because the effective speed is essentially the instructions per second, and for some reason Game Boy developers seem to quote the speed as the instruction per second, not the actual processor speed. The processor speed is 4 or 8 megahertz, but they talk about it like it's actually 1 or 2, because of the 4 cycle thing. But if you were going down that route, then you could argue that the C64 is only half a megahertz, because there are no instructions on the C64 that are less than 2 cycles. So everything is at least 2 cycles long, which means you can only have 500,000 instructions per second, 0.5 MIPS. So it's a kind of, it is kind of weird. I don't know why that is the case, but it does seem to be the case with Game Boy, that people talk about the processor in terms of MIPS rather than the actual processor speed. Right, okay, so I can see one problem straight away is if I hold up on jump, it constantly goes up, and that's because actually while I'm falling I can still press jump, so I've got like a double jump routine. If I press it right at the top of my arc, at the very top of the arc, there is no fall set, there is no jump set, so you can jump again. So I think we need to make sure that fall is set when we're at the end of the jump. So at this end jump here, we're going to end it with state jump to turn the jump off, but then we're going to OR it with state fall, which is going to turn the fall back on, and this should prevent the double jump sort of thing. So let's have a look. Yeah, there we go. This does seem really quick though. I think we might need to slow it down a little bit more, but it'll probably feel less of a problem once the rest of the game's in. I mean, we've got no side collision at the moment. We've got collision where we shouldn't have collision. These things shouldn't have collision on them. This, you shouldn't be able to stand on the top of that. You should just walk right past it like this. You certainly shouldn't be able to jump on the chains and things. But this is looking pretty good. So I would like to maybe try and solve this this adjustment issue here. Could the game also be ported to ZX Spectrum? How much of a rewrite would it require? It probably could be ported, but the problem is my problem with this game is that the game, and this is the reason I've gone for Game Boy Color and not the original Game Boy, is the game relies heavily on this this effect, which I'll show you here if you've not seen the game before. It relies heavily on a timeline changing effect, and the idea of the timeline is it should change between a modern looking graphics mode, or modernish for the C64 in this case, this kind of graphics mode, and a much older style graphics mode. Now on the Game Boy, on the original Game Boy, that's going to be really hard to do because you only have 4 colors. There isn't really a lot you can do with it. So what I've done in here is the Commodore has this Petsky font, so it's quite easy to create that effect of an old timeline. I've got no power, so just to show you. Okay, so any time you can switch between these two timelines. So on the Game Boy original, that would be difficult to do because there's not going to be a lot of distinction between the two game modes. On the Game Boy Color, that's going to be a lot easier to do because what I'm actually going to do is I'm going to switch between the Game Boy Color look, which is going to be like this, and the original Game Boy. So when you click the button, the graphics themselves won't change very much. Then some of these things may get removed, and some of the animation like this might be removed, but the the palette will change to the original Game Boy palette, so you'll get that you'll get a feeling of you going back to the original Game Boy, but switching between the two. So the ZX Spectrum, again, that's going to be quite hard to do because the ZX Spectrum doesn't have a lot of stuff to do with the graphics. I mean, you could change the color, maybe make it monochrome, but it wouldn't work that well. So that's why I mean, I'm not saying it couldn't be ported. It probably could be, but I think the game design doesn't lend itself very well to the Spectrum, unfortunately. 6502 can do 0.43 instructions per clock. Okay, so yeah, 0.43 on average. The Ryzen 3958, which I got in here, can do 10.18 instructions per clock per core. Okay, so it's doing 160 instructions per clock, which is insane. 6502 instructions take less on average than the Z80. Yes, so the Z80 takes 4 cycles minimum to do things, whereas the 6502 takes 2 cycles minimum. Also, I mean, you can tell just looking at code. I mean, look at all the stuff I have to do what is essentially quite simple stuff. So like this bit here, I mean, all right, this is made worse because this is the Game Boy Z80. We don't have index registers, but in all of these instructions are basically doing this. Actually, that would be load accumulator with Y. There you go. So all of those instructions are basically doing that in 6502. So you can see that the cycle usage is going to be a lot less. Also the byte usage as well. The byte usage seems to be way less in 6502. Actually, there's one extra line I'd have to do. Let's put it back again. But that's 5 lines versus 11. Byte-wise, it's probably not too different because I know a lot of these commands, things like this and this, are just 1 byte commands. But line-wise, it's a lot easier to read. I think 6502. C64 should have used the Z80. I'm glad they didn't. I'm really glad they didn't. I think they did the right thing by buying MOS and basically just sticking with it. I think it's the best of the 8-bit processors that I've used so far. So I'm really looking forward to 4510 as well. That looks really good. So. Yeah, they bought MOS because I think of the cost saving implication. I think when they were doing the VIC-20, I think they bought it and basically said, "You make chips for us now." Thank you for the follow, Pink Maple. Welcome to the stream. Okay, so I'm quite pleased with this routine now. I'm going to take a short break. Actually, it's a little bit earlier than normal, but I'm going to take a short break now. And then when I come back, we will. I don't know what to do next. Actually, let's have a look what we've got. Let's close all of these. Let's close the C64 down. Collision table would be good actually, so we can actually deal with stuff like this. So maybe I'll start looking at how to do that. I mean, ideally this should be something that, oh no, we'll sort this glitch out here. So we're going to try and look at why the sprite can be moved down through this area, which I think is just about where we do the collision check. So yeah. All right, cool. I'll be back in 2 or 3 minutes, guys. Be right back. Cool, and I'm back. I gotta say, having the wired headphones is a lot better. I don't have to worry about charging things between brakes and stuff, so it's a lot better. And I think I've managed to catch every alert so far, which is a big change for me. Okay, so we're going to see if we can figure out what this is. Is there a way of slowing this down? I don't think there is. I think I looked at this before. Options, system. God, I don't know. Debug. I think I looked at this before and I don't think there was a way. Moss seeped waste into the ground. It's still being monitored. Oh wow. I wonder if there's any SIDS buried in the ground down there. That's what I'd like. An endless supply of SIDS, that'd be great. So this is kind of what I want. The jump. Actually, I think we might need to slow the jump down a little bit because he needs to be able to jump a certain distance, and at the moment he can jump basically one tile, which is not enough. Let me just check on here what it should be. It should definitely be more than one tile anyway. I think it needs to be probably needs to be about 2 tiles. Oh, it's up, isn't it? So let's jump from this tile here. So why not? So actually it can cover 3 tiles, but that will have to be reduced slightly. Whereas on here, he's jumping. Actually, his jump is really quick. His walk seems to be about right. Actually, no, his walk is a bit slow as well. Let's try speeding his walk up a little bit. Let's just put an extra one of those commands in. An extra one of those. So he's walking 2 at a time. Oops. Seems a bit fast now. Doesn't help that I'm bumping into absolutely everything on the screen. Yeah, his walk seems really quick now. Let's. I think we're going to have to play around with the. We might need to introduce fractional positioning for the main fractional positioning for the player X and Y just to get this right, which I really don't want to have to implement because that's going to be a frigging nightmare when it comes to Z80, but we might have to just suck it up and do it. But see, that's too slow now.
Look, I got an idea.
Also, the fall seems to be. We might have to tweak these values quite a bit, I think, but we can do that at a later date. It's fine. For now, I'm just going to leave it as it is with the timings that it's on, and we can adjust those later on. I want to fix this issue here. So the issue we've got is when I jump. One of these is causing us issues. So player control is just what is kind of setting our left and right at the moment, whether or not we're jumping. Player collision is what's going to deal with whether we're falling or not. And I think it's that needs to do. are snapping, and it's this bit here that's doing the snap. So I'm gonna take that and I'm gonna move that down to here. Snap if not fall dumping. I've completely lost the code for some reason. And so let's put a no snap here, and then we need to like this. So this will be load player state with jumping or falling, and the result of that is non-zero, then no snap. Hopefully that might be enough to just fix that. I think it has. It looks like it has. Yeah, it has. It doesn't seem to be drawing any frame. Oh, actually, I saw a tiny glitch of it going through, but I think that's a lot better. You can see it every now and again. You see these lathes go through. It's only by 1 pixel, which is... I wonder if we change the bits here to 1, 1, what will happen? No, we still get it going through. Now, is that because we don't check after we've updated? Ah, okay. I think we need to switch this around a little bit. So at the moment we do the fall only if these values are set, whereas I think these should be done just before the snap. So let's move this here. Okay, I need to adjust that in a second. We will need to change. We'll keep that as it is. I like the fact that it only checks 1 at the top. We need to change this to only do the falling if we're actually falling. So like so. And then this one would actually have to check if we're... Okay, so yeah, so we just need to move this. We need to split this up a little bit. So this will become a check here first to see if we're already falling. In which case we don't need to do. Oh no, we do need to do this. So actually, it's literally just this, I think. call that snap, and then to snap here, and then no apply fall will basically turn the fall off. So this is going to actually add the fall. Already falling, so don't need to do that. Otherwise we do apply the fall. Otherwise, if no apply fall, then we need to like so. Let's give that a try. I may have messed things up massively here, but let's give it a try. Let's just check that that code is actually filed. It has. Okay, the jump doesn't seem as high anymore. And the jump seems incredibly small. But it's no longer, you can see there, it's no longer falling into that gap there, so that's good. So we just need to fix that now. That's not quite correct, so. So we change this now into a system that is going to apply the fall if we're falling. It's going to apply the jump if we're jumping. Which means this is no longer of use. Just make sure that doesn't change anything. It shouldn't do. Yeah, it's the same. Okay. And then our fall collision, no apply fall. Okay, so this, okay, right, so if we are falling, then we need to keep checking if we're falling. But if we're not already falling, think about this. So what's happening here is we're jumping, and then in the middle of the jump it's doing this, it's turning, no, oh, it's looking to see if I need to fall, and if I am falling it does here. So what I need to do here is check if we're jumping. So you only check fall collision if we're not jumping. So something like this, and then jump if non-zero to snap. And that does a similar check here with the, in fact it would be no snap, because there's definitely not going to be any snap if we're jumping. So that should give us the same jump routine now, but we should be tied neatly to the yeah, there we go. It is really quick though, that we're definitely going to have to adjust that. It still seems to be going through though, annoyingly. It's definitely a lot better though. If I'm falling, then it comes through here, it checks this, it will adjust if I need to adjust. Don't apply fall, so Yeah, it does look a lot better. I'm gonna continue till about midnight, and then I'm gonna switch over to playing some Last of Us. So I'm gonna have a play around with these tables a little bit, because I think if I just expand the length of these tables, then the jumps will slow down a little bit, and they should look a bit smoother. But we need the total to stay the same, so I'm going to try and do that now by adjusting these values. So that's 12, and that's 10, and this is 18. So let's see if I can get to 18. So that's 12, so 2, 2, 2. Right, so that's 18. Then I've got another 6, and then another 6. So I need another 12. So I'm going to do 4, and then basically that twice. So that's a different jump table now. Actually, I'm just going to comment the original one out, which hopefully should slow the upwards movement a little bit. Okay, I don't know why it's suddenly doing that on 4, but that doesn't look natural at all now. Okay, I think I need to manually work these out. I think that jump is too long now, so let's calculate. So 10, 18, 24, 30. So it moves 34 pixels is the upward trajectory here. So let's try and get this close-ish. So while retaining kind of the smoothness of it. So that's now 17. So that's 20. So that's 30. That's 34. Okay, I think that the upwards looks a lot better, so I just need to get the fall now to slow it down a little bit. So the fall is so this is a bit different, right? So this is when it gets to the end of this table, we'll just keep repeating this value because it's a fall. So this is like your terminal velocity when you reach this value. So actually it could be like that. It doesn't have to have multiple 5s on the end. So I think I need to reduce the terminal velocity down to 4. So let's just duplicate this line so I can compare it if I need to. It could do fractional movement. Yeah, I'm considering this is something I might have to do. Terminal velocity. Now that was I remember that being a game shortly after Doom or Quake, I think it was, and it was kind of a really cool shooter kind of game, a little bit like the Star Wars kind of some of the Star Wars games. I remember it being pretty good actually, so I might have to play that at some point if I can find it. I bet I can't find it. Let's get somewhere. It's kind of alright. It's less janky than it was before. Oh, look at that, we've got a weird sprite up there. I don't know why that's appeared. We must be setting some sprite values somewhere. It's going to be fun to work out why that's appeared. I want to try and avoid using fractional if I can. I don't use it in the original dock at all, so I'd like to avoid it if possible. Okay, I want the top of his jump to last a little bit longer, so I'm going to put I'm going to change these to 1 and then stick another one of those on as well. Okay, yeah. Trying to do smooth movement on wheels, but apparently moving 1 pixel per frame is not smooth. It should be. Definitely should be. Oh, Zupadan, yeah, 3D. Yeah, it was really good. I would like to play that again, actually. Love to see it on modern hardware. Probably looks terrible now, but I think my update routine might be called more than once per frame. It goes super fast. Yeah, so if you move 1 pixels per frame, it should take you about 6 or 7 seconds to cross the screen. So you probably are calling it more than once. Also, bear in mind as well that you are going to see slight glitches in movement through the emulator. It's only when you run it on real hardware you'll see how smooth it really is, because you'll get that weird 50 to 60 frame disparity, like desync that goes on. So you will get slight glitchiness as it moves, but it shouldn't be terrible. I feel like it falls way too quickly. So I'm gonna put another 2 of them in. Oh yeah, make sure you do all your sprite updates off screen as well. That feels better. Yeah, that feels a lot better. Okay, cool. There's still some really annoying kind of single frame glitches through the scenery, but I don't understand why they're happening though, because we're doing the correction now as part of part of this routine now, so it only snaps. Oh, snap if not jump or fall. Maybe it thinks it's still falling, in which case this has failed. Get char position. From sprite 0. Maybe this is actually reading sprite data rather than shadow data, or player Y as it actually should be. So actually this shouldn't be player collision, this should be something else. So what we should be doing is applying the jump and then applying collision here. The reason we need to do that is because then we can, so player collision, we'll call this player jump and fall. Player collision can be done every frame, there's no reason not to do it every frame. However, I am going to slow it down because it may as well match the speed of the jump and fall. There's no reason for it to not match that as well, so it'll save us a bit of processing time. And then in here, once we've set the player sprite, then we can call the collision. Oh, actually no, because that's gonna... Okay, so call... I'm going to keep them separate because I think it's nice that they're separate. But when we go to set the player sprite, actually no, the collision in here this is loading a sprite based on this. So actually the player Y here. So if A is 0, we need to make a very specific case here for if A is 0. So shit, yeah, this is not gonna work. So the reason this is happening is because when we set the player sprite, well, maybe we can do it from here. But if we do it twice, it fixes it. But if we do it twice, it fixes it. But I don't want to do it twice. Yeah, it does as well. God damn. So what's happening is this player jump and fall is affecting this value here, player Y. Player control is affecting player X. But the collision routine is actually looking at the sprite definitions. And so it's adjusting based on the previous frame, because the set player sprite is what's converting player X and Y. So by putting another set player sprite in here, we actually update the sprite with the latest data. So maybe, actually, let's have a look how big that set player sprite routine is. If it's not too big, then I'll keep it in. I don't think it is that huge, actually. Okay, there's no loop in here. Yeah, it's kind of fine. All right. Make it the last line of screen, at least for that vertical line. Should be off screen. Yeah, the last line is well, ideally it needs to be where your sprite isn't. So if your sprite, it should be just after your sprite is drawn. But I would suggest doing it at the end of the screen. That's probably the safest bet for these things. So let's have a look. Essentially, let's see, 25 plus 50. Yeah, 120 is enough speed. No, he's that. Yeah, 250. Yeah, I think you need to. I think you probably need to set a proper IRQ up rather than use that compare and branch thing. That's probably not helping as well. It's good for kind of quick testing, but for a proper game loop, you're going to need an IRQ set up to handle all those things. I would suggest doing it same as I've done it here. Basically, have your IRQ. Have your IRQ set a flag when it's finished. Set your IRQ to run at whatever line. Have it set a flag when it's finished, and then have your main loop only access stuff, only run once that flag is set. Oh, okay, using proper IRQ. It should be fine then. Make sure you acknowledge your IRQ as well. If you don't acknowledge your IRQ, then what's going to happen is it's just going to run straight away again. So it could just be that. So make sure you do this at the end of your IRQ. That could be why it's moving really quickly, because if you are moving it 1 pixel every time the IRQ fires and you don't acknowledge the IRQ, what will happen is as soon as it's finished, it will run the IRQ again and then it will move again. So you'll be moving at ridiculous speeds across the screen, and it will be happening all over the screen as well. It won't just be happening on that line, it'll be happening wherever, because the IRQ never exits. Yeah, there's a really good chance it's that. It might not be, but it's a good chance it could be that. But yeah, I would recommend using the frame ready flag to make sure that your IRQ is doing the minimum amount that it needs to do, and have the rest of your code running outside of an IRQ. That way, if you need more IRQs later on for doing splits and things, you will have a lot easier time setting them up than if you had an IRQ full of code that was taking many lines to complete. So. Okay, I'm feeling pretty confident with this now that this is in a good state. I think the jump routine is, I mean, it's not quite there, but it will do for now. I think it's going to need some adjusting. I think once we get the rest of the map in place. Oh, that's not right. Oh. So after saying all that, it's gone into a weird mode. I'm not sure how I got it to do that, but apparently I can get it to freak out like so. Oh, I think this is the pixel that I'm checking on, because I'm now checking on 1 pixel lower than I should be doing on a collision check, which was this bit here. There's a chance that sometimes it will be checking 1 character lower than it needs to be, so if I just reduce it to that, it should solve that issue. Yeah, that seems to fix that issue. But, and it has got rid of that glitch, which is fine. I don't mind the little bit of extra time that takes to do that. It's a couple of cycles, it's not that much at all. Okay, cool. I am going to switch over now to PS4, so I'm just going to push this stuff to my repo. Fix right background condition. Shadow map.